All right, so we're going to start a new section, new functions to integrate. So remember the integration, when we talk about integrals, we were talking about antiderivatives. So we have a function, we want to find the function whose derivative would be our original function. And these are getting a little bit more complicated than what we saw in the last section. And typically if you go on to Calculus 2, they're going to get more complicated as you go along. And you're going to see that it's not quite as straightforward as derivatives. You might know the technique, but there might be, not that there are multiple ways to do it, but there might be, you have to decide which option you want to use. So let me illustrate what I'm talking about here. So we want to integrate this function 8x times 4x squared plus 8 to the 6th. If we wanted to find the derivative of this function, that would not be too difficult. We'd use the product rule, we'd use a chain rule. But with integration, we are going to use what's called substitution. Now, what you want to notice is you have this 8x and you have 4x squared plus 8. Now, if you took the derivative of 4x squared plus 8, what do you get? You get 8x. Now, that is helpful in this problem. So we're going to use what's called a U-substitution. This section is called substitution. Some books will call it U-substitution. And the reason is we're going to let part of this function equal U. No reason to pick U other than that's kind of the standard that we use. So the way you decide what U is, of these two, we have 8x, we have 4x squared plus 8, which 2 would be the original function, which would be the derivative. So 4x squared plus 8 is not the derivative. 8x is the derivative. So if we let u equal 4x squared plus 8, we can let du equal the derivative of u, which is 8x, dx. Okay, so let's use a couple different colors here. And so let's choose green. Choose green. Let's let green maybe, or maybe we won't do it this way. All right. Did we pick green? Did we pick green? Yeah, it looks like we did. So no, maybe not. All right, so here's our 4x squared plus 8. That matches there. Here, we'll just use a squiggly line. 8 du equals 8x dx. So we have the squiggly line around this. So now all the variable parts of this function are accounted for. It's either in the u or the du. So now if we substitute, we have the integral. 4x squared plus 8 is u, and that is raised to the 6th. So we have u to the 6th. And then we have 8x dx, and that is equal to du. So this integral becomes u to the 6th du. And we learned how to do functions like this in the last section. This is 1/7 u to the 7th, and then plus c. So if you remember, in this case, we'll use u. In the last section, we used x, but just a variable, so it doesn't matter. But if we have u to the n, and we want to integrate that, we would write that as n plus 1 in the denominator, u to the n plus 1 in the numerator, and then a plus c. And so that's all we've done here. And now we substitute back. So u is 4x squared plus 8. So this becomes 1/7 4x squared plus 8 to the 7th plus c. And there is our integral. And you can check it if you take the derivative of this, use the power rule, use the chain rule. So 7 times 1/7 becomes 1. We'd have 4x squared plus 8 to the 6th. Take the derivative of what's inside using the chain rule, and we get 8x. So 8x times 4x squared plus 8 to the 6th, which is our original function. So we have found the antiderivative using substitution. All right, let's see this one. And we'll talk about more, I guess, I guess, better guidelines. I don't know. I mean, what I'm giving you as a guideline here is good. We'll give you more guidelines in a minute. So here we have x cubed times square root of 3x to the fourth plus 10x. Now, we have two parts of this, and maybe we'll rearrange the order here. Let's write 3, we'll put the square root part first, and then times x cubed dx. We haven't changed anything, we're just regrouping these things, which we can do since we're multiplying. So now 3x to the fourth plus 10 and x cubed. Now, if you take the derivative of this, you would get this, kind of. At least close. Obviously, we got the 3, but if we only consider the x to the fourth, and you take the derivative of that, that'd be 4x cubed. So we're almost there. The thing you want to look for when you're looking for what is u and what is du, you can kind of pick either one. I mean, you know the two options. One option is 3x to the fourth plus 10. The other option is x cubed. If you take the derivative of this, you get 3x squared. Well, it's more important for the variable and exponent to match up than for the coefficient. In other words, the derivative of x to the fourth is an x cubed function, or a cubic function, and that's what we have here. So let's make u be 3x to the fourth plus 10. Du would be 12x cubed dx. And so now we're almost there. We have an x cubed dx, we have an x cubed dx. We got this extra 12 here. So let's divide both sides by 12, because really whatever we have here is what we want just by itself. So we want to solve this equation for what we have here. So that gives us du over 12 equals x cubed dx. Okay, so now we have this, and then we have our squiggly part, like that. So we box that. We have a squiggly part around that, and now it's just making a substitution. So we have square root of u, so we got the integral square root u, and then x cubed dx is du over 12. We can pull out the 1/12, so let's write 1/12, and we'll write square root u, but we'll write u to the 1/2 du. And now again, it's just a very simple integration problem that we were doing in the last section. So add 1 to the exponent, that'll give us 3/2, and then divide 1/12 divided by 3/2, and so that would be 1/18, I think. U to the 3/2, 3 over 36, yep, that works, plus c. And then let's substitute back. U is 3x to the fourth plus 10. So 1/18, 3x to the fourth plus 10 to the 3/2 plus c. And again, you take the derivative of this, and you should get back to this, and you will. So let's talk about how do we decide what u is. In all these problems, there are only really two options to pick for u. And so you can pick one and see if, so for instance, let's do this the wrong way. You can pick one, and then if it doesn't work, it should be obvious. So we chose u equals 3x to the fourth plus 10. Let's say that we chose wrong and picked u, so this is the wrong way. But I want to show you that you can do the wrong way, and you can figure out that it is the wrong way. So if we let u equal x cubed, then du would be 3x squared dx. Now, the problem is we have 3x to the fourth plus 10, so there's no way to turn this into 3x to the fourth plus 10 dx. So there's no way to get this to be something equals 3x to the fourth plus 10 dx. So there's no way to do that. You can't multiply it. You can't multiply an x anywhere. You can really only work with the constants. So whatever you have on this side needs to look like some part of this. So when you pick a u, the du will help you figure out if you did it right or not. Because if you do it wrong, it's not going to look like what you had left over. So in this case, we started with 3x to the fourth plus 10. Take the derivative, now we have an x cubed dx. That's almost what we need. We have 12x cubed dx. That's almost what we need. So we can divide constants. Can't really do anything with variables when we're figuring out what the du part is. All right, so in general, we have three cases. So we can choose u to either be the quantity under the root or raised to the power. So those are both ones we've done so far. The quantity in the denominator, which is what we're going to do here, or the exponent on e. So if you want to integrate, say, x e to the x squared dx, you would let u be x squared, you would let du be 2x dx. And so you got the x dx, so you divide this by 2. We get du over 2 equals x dx. U is x squared, so then this would become the integral of e to the u, and then x dx is 1/2 du. And so then you can integrate that. Now, this one, number 3, we have x plus 3 over x squared plus 6. So what is u going to be? Well, this says typically it's going to be the quantity in the denominator. So let's choose u to be the quantity in the denominator. And then we get du is 2x plus 6 dx. Now this doesn't look quite like what we need. We need it to be x plus 3. But you can see that if we factor out a 2, then we have 2 times x plus 3 dx. And then we can divide by 2. And we get du over 2 is x plus 3 dx. So then now we have our squiggly part here. And then we have our box for the u. And so all of the parts of this function are accounted for. So this will become the integral. We just have a u on the bottom. And then we have 1/2 du up here. Or if you like, you can write 1 over 2u. Or if you like, even more, you can factor out the 1/2. You get 1/2 times the integral of 1 over u du. Now we talked about the integral of 1 over u. That is just ln of u, ln of the absolute value of u plus c. And then we can substitute. We get 1/2 ln x squared plus 6x plus c. So you're going to use this one. Obviously, most of the problems in this section are all set up to do this. Typically, these problems look like either you're using the quotient rule or you're using the product rule, and maybe not using the chain rule. But definitely using either the quotient rule or using the product rule. Or if it's an e, well, even then you're going to be using the product rule because it looks something like this. Or you could have an even more complicated function if you have x plus 2, e to the x squared plus 2x, something like that. But you can be using the product rule or the quotient rule. So, all right, learn these 3 things to look for. And if you have any questions, please let me know.